Welcome all of you. Welcome to another video of Maths, and this is Anandita. So in this video we are going to take up circles, but then this is the third part of circles where we are going to take up cyclic quadrilateral questions. So this full video we are going to do only cyclic quadrilateral questions based on cyclic quadrilaterals. In the previous two videos we have done chord properties and we have done angles subtended by arcs. Okay, so in this one we are going to take up cyclic quadrilateral sums only. So you can watch the video from the beginning to the end. This is a very easy concept and a frequently asked question in the exams. So I have tried to take up some typical questions and some important questions of this chapter, and which are generally asked in the exam, and I have tried to explain it. So let us see how to work them out. So cyclic quadrilaterals. Okay, cyclic quadrilaterals. This is the next topic that we are going to take up. Now, what is a cyclic quadrilateral? If we have a circle, then if we have placed a quadrilateral inside a circle, all the four vertices must touch the circumference, then it makes a cyclic quadrilateral. Otherwise it is just a quadrilateral. Okay, so you are not supposed to draw the quadrilateral over here. It should touch all the four sides, then it makes a cyclic quadrilateral. If this is a cyclic quadrilateral, in that case what are its properties? Now it's not necessary that a cyclic quadrilateral should always have a circle around it. If we can just prove the properties of a cyclic quadrilateral, that is enough to say that it is a cyclic quadrilateral. We don't need a circle all the time. Now here in a cyclic quadrilateral, the first property is, if this angle is an x, this has to be a 180 minus x. If this is a y, this is 180 minus y. That is, opposite angles of a cyclic quadrilateral are always supplementary. That is the first one. Okay, and the second property of a cyclic quadrilateral is very simple. This angle is called the exterior, not just this. I can make it here also, and I can make it here, and I can also make it here. This forms one set of exterior angles. So this angle, let's say P, this angle P or CB, whatever it is, X, this angle is equal to this. That is, exterior angle of a cyclic quadrilateral is equal to interior opposite angle. Okay, exterior angle of a cyclic quadrilateral is equal to interior opposite angle. This is exterior and this will be equal to this angle. Means if this is x, this also is x. If this is a, let's say 50 degree or let's say 80 degrees, whatever, then this is also 80 degrees. Similarly, if this is a 90 degrees or let's say it is a whatever angle, then this angle will also be a 90 degrees. If this is 70 degrees, this is 70 degrees, like that it goes. Okay, so cyclic quadrilateral has these two rules. One is opposite angles of a cyclic quadrilateral is equal to 180 always. So this and this make supplementary pair, these two make a supplementary pair. This one equal to this, this one equal to this one equal to this, like that. Okay, we can even make another exterior angle like this. This is also one, extend any one of the sides. This is also an exterior angle. If you extend this, this forms an exterior angle, not this. Okay, the one with the side of the quadrilateral makes an exterior angle. You can form one more here. This is an exterior angle. Okay, so you can have two sets of exterior angles, and every exterior angle is equal to the sum of the interior opposite, and it's very easy to prove also, because if we have a, supposing this angle is 180 minus x here inside, and this is an x therefore, and due to supplementary pair this is again x. So this is x due to linear pair, this is x, this angle is x due to supplementary pair, but finally these two are equal. Okay, with this we'll start with our sums. These are the concepts, exactly these are the concepts that we are going to use in our sums right now. Okay, let's see. So this is the sum. This is the first question where we have, this is a circle and where we have AOB. Okay, so we have AOB as the diameter, O is the center of the circle, and they are asking us to find the sum total of these two angles. Now which are these two? ACD plus DEB. Okay, these two angles. Now how do we find it? So the very first thing that we can do here, this is not a cyclic quadrilateral. 1, 2, 3, 4 and 5 sides. It is not a cyclic quadrilateral. So what we can do is, we can join this. Okay. Now we have got angle in a semicircle. ACB is angle in a semicircle. So angle ACB according to our angle subtended by arcs is a 90 degree. We have done it in the last video, that any angle in a semicircle is going to be a 90 degree. Once this is a 90 degree, then we can find this angle, this much, plus this is a 180. That is angle DCB plus angle DCB plus angle DEB. This should come to 180 degrees. This is a 180 degrees. Now why is it a 180 degree? Because these are opposite angles of a cyclic quadrilateral. Here this full angle is a, we can write it like this, angle DCB plus angle ACB plus angle DEB. Now how much is that equal to? Angle ACD plus angle DEB. That can be written as angle ACD can be written as ACB plus angle DCB plus angle DEB. Okay, so when we write this, angle ACB is a 90 degrees plus this portion DCB plus DEB is a 180 degrees. So the total comes to a 270, means angle ACD plus DEB sums up to a 270. I'll repeat, this is a 90, this plus this is a 180. So practically what we did is, this one plus this is 90 plus whatever it is. So we take this 180 plus add the 90 to it and we get the sum total of this and this. That gives us a 270. Okay. Now this is a question which says find angle BCD. Angle BCD. And here we have a figure like this in a circle where this is, okay, we'll have to join this also, where this line CD is parallel to AE. That is the only thing they have given us. This angle is 20 degrees given to us, this is 92 degrees. And they want us to find angle BCD. BCD is this angle. Now how to find it? Now the very first thing, if they have given us this parallel lines, it is for a purpose. So here, if this angle will be equal to this part of it. Okay. So if this is 92, angle ABC is a 92, then here angle ADC will be 180 minus 92. As you know, opposite angles of a cyclic quadrilateral are supplementary. So and that comes to 88 degrees. Okay. So this angle comes to an 88. If this angle is an 88, immediately I can say this angle is also an 88 because these are alternate angles. Now if this is an 88, this full angle, that is angle FAD, angle FAD becomes 108 degrees. If this is 108, then this angle is also 108. Therefore, angle BCD is equal to 108. That is exterior angle of a cyclic quadrilateral is equal to interior opposite angle. I have already talked to you about this. Okay, so this angle becomes equal to this one. So that is the whole. The sum was looking very tough, but then only by using this parallel lines, alternate angles, and then adding this up, we don't even have to find this. Sometimes people find this. If you want to find it, you can. This can be a 72. If this is a 72 again, with this you can make it. This is 72. This is 108 again, because these two are opposite angles of a cyclic quadrilateral, so they are supplementary. That way also you can find it, but then I took a shortcut. I got it straight from here and here. Okay, here we have one sum which says find x and y. Now we have a cyclic quadrilateral here because they have told us O is the center and then this line is passing through the center. Okay, so if this line is passing through the center, then this is the diameter. In that case, this part OA is equal to OB because they are the two radius. Therefore, this is also 50 degrees. I'll solve the sum first and then I shall write it. So, this angle is a 50 degree. If this angle is a 50 degree, then we can say that this much, this angle AOB is 100 minus 180 minus 100, and that is an 80 degrees. If this is 80, angle x becomes 100 degree. If angle x is 100 degree, you should not take this as an 80 degree because this figure DOBC is not a cyclic quadrilateral. Very often people do this mistake. Okay, so clearly this is a straight line, isn't it? This angle, this is a straight line, so it is 180 and we are in a cyclic quadrilateral. Okay, if we are in a cyclic quadrilateral, one side, two side, three side and four side. So in order to find y, we should take this one and this one becomes supplementary. Okay, so this becomes 180 minus 50 degree, which is a 130 degrees. Okay, so let me now write down the steps. Angle OAB is 50, that was given to us. Therefore, angle OBA is also 50. Angle AOB is equal to 180 minus 100, that is 50 plus 50, that is an 80. Okay, angle DOB is 180 minus, DOB is 180 minus 80 degrees, this one, okay, which is angle x. So DOB is x degree is an 100, is a 100 degree. Okay, so we got this. Now we are going to get this. We are back in the quadrilateral. We'll keep counting the sides 1, 2, 3 and 4. Okay, so this makes a quadrilateral. Therefore, angle OAB plus angle DCB is equal to 180. Why? Because they are opposite angles of a cyclic quadrilateral. Okay, opposite angles of a cyclic quadrilateral. If so, now we can write, therefore we can write that angle Y or DCB is equal to 180 minus 50 degrees, which is a 130 degrees. So we have got the value of x and we have also got the value of y. So this sum was slightly, it's not tough. It is just, difficult to realize that this is also a quadrilateral. Once you do that, you can get this sum easily. So here I have a figure like this, which looks, there are two combination of circles and nothing else has been told. The two circles are intersecting at D and C. This angle is given as 75 degree. We are supposed to find x and then find y. Okay, so we are not going to consider this big one as a cyclic quadrilateral. They give us scope for mistakes. But then we cannot take this big one, that is ABFE, as a quadrilateral. We will take ABCD as a cyclic quadrilateral and we'll take this. This becomes 105 because 180. supplementary, opposite angles are supplementary. If this is 105, this becomes a 75 degree. If this is a 75 degree, then angle Y is again a 105 degree. Okay, so how do you write it? And you can even write straight angle DCF is equal to X is equal to 75 degree. What is the reason? Exterior angle in a cyclic quadrilateral is equal to interior opposite angle. That is coming from the theorem. Okay, so we got this as a 75. Then angle Y is equal to 105 again. Why? Because it is 180 minus 75. Why? Because opposite angles of a cyclic quadrilateral. Opposite angles of a cyclic quadrilateral are opposite angles of a cyclic quadrilateral are supplementary. Hence, Y is equal to 105. Okay. So, with just 2 steps, we complete this sum. This sum can come for about 3 marks in the exam. Okay. So, this is it. Y is equal to 105. So, we got all the required angles of this figure. Here they have told us that AB and CD are 2 parallel chords. Okay, they have given us AB parallel to CD, and then they want us to prove that triangle AEB is an isosceles triangle. Okay, they want us to prove this. How do we prove it? So, very simply, if this line is parallel to this, okay, and it is also a cyclic quadrilateral, I can see. This is 180 minus x. From the property of cyclic quadrilaterals, opposite angles are supplementary, okay, in a cyclic quadrilateral. Now, if this angle is an x, then this will be an x because of corresponding pair. If this angle, that is EDC, is an x, this much, then this becomes a 180 minus x. If this angle, that is angle BDC, is 180 minus x, then this one BAC will be an x. Why will it be an x? Because opposite angles should add up to 180 in a cyclic quadrilateral. Now what do we see? We had started from x and these 2 angles have become equal because both are x's. If these 2 angles are equal and both are x's, we can say BE is equal to EA. Therefore, the triangle is an isosceles triangle because base angles are equal. So, how do we write it? Let us now see how to write it. There are few statements we have to write. Okay. First statement will make this 180 minus x. Angle DCA is 180 minus x. Angle DCA is 180 minus x. Opposite angles of a cyclic quadrilateral. Okay. Opposite angles of a cyclic quadrilateral. Hence, it is 180 minus x. Now, angle EDC is an x. Corresponding angle, because lines are parallel. So, we have to keep that in mind too. Corresponding angle. Angle BDC is 180 minus x, supplementary, or you can say linear pair, or angles in the same straight line, anything. Okay. So, this is a linear pair. Now, you can say, therefore, angle BAC is an x. Why? Because it is, you can write it in brackets here. BAC is, or you can write it like this. Maybe you can write it like this. Angle BAC plus angle BDC is equal to 180. Why? Opposite angles of cyclic quadrilateral. Okay. Now, here we don't know BAC, so we'll just keep BAC like that. And the other one is 180 minus angle BDC. Now how much is angle BDC? 180 minus 180 minus x, which is 180 minus 180 plus x, which is equal to x. Okay, so angle BAC now becomes an x. Then what can we write? Therefore, okay, therefore, so we can write therefore EB is equal to EA, because angle B is equal to angle A. Okay, this is the reason. And then we can write triangle EBA is an isosceles triangle. Here base angles are equal. Okay, base angles are equal. That is all we need to write. So base angles are equal, hence this is an isosceles triangle. Why? Because we have proved both the base angles to be x. We have proved both the base angles to be x, hence the triangle becomes an isosceles triangle. So if you start writing in the diagram, you will see that you are getting your sum much easily. Okay, so get into the habit of, rather than thinking, you must copy the diagram in your note, in your paper, and then start filling it up with angles, and the sum comes up in no time. Here is a sum where they have told us ABCD is a quadrilateral. Okay, ABCD is a quadrilateral. They haven't even told us that it is a trapezium. It looks somewhat like a trapezium, but they haven't told us. Angle ADC is equal to angle, that is this angle, is equal to angle BCD. This much is given. And one more thing that is given is AD is equal to BC. Okay, AD is equal to BC. These few things are given. Okay, now we are going to prove. What do we have to prove? Prove that ABCD lie on a circle. When they use this kind of a statement, this is why I picked up this sum. When they use this kind of a statement, it means it is another way of saying that ABCD is a cyclic quadrilateral. Okay, and all you need to prove that a figure is a cyclic quadrilateral is that opposite angles add up to 180. Okay, so ABCD lie on a circle. Now, here if this angle is, what we'll do here, we'll forget about this angle, we'll just make two perpendiculars. We'll make two perpendiculars from here. Okay, so there is a construction. So in the construction we will draw DE and DF perpendicular to AB. Draw DE and DF perpendicular to AB. In that case, draw DE and DF perpendicular to AB. Now here, if this angle is a 90, remember this side also we have a 90. We are in this triangle AED and triangle BFC. We are in these two triangles. We are talking about these two triangles. This side is equal to this that has been given to us here. Okay, they had given us that this angle, full angle, was equal to this full angle. But then here to here, okay, if it is a perpendicular, then here to here is a 90 degree. Okay, if this is a 90 degree, then this small angle, that is angle ADE, is angle ADC minus 90. Similarly, angle BCF is angle BCD minus 90, and ADC is equal to BCD. Yes, so these two angles, therefore angle ADE is equal to angle BCF, while ADC is equal to BCD. That is why. Okay, so we have these two angles, that is this small two angles have become equal. Then we have angle, the next part is angle AED is equal to angle BFC. Angle AED is equal to angle BFC, that is these two 90 degrees. And also AD is equal to BC. AD is equal to BC, that is again given. Therefore, we can say triangle AED is congruent to triangle BFC. Triangle AED is congruent to triangle BFC, and therefore by AAS. Now what can we say from this? From this we can say that this angle is equal to this angle. So how do we write it?